Dynamic game worlds are only as active as the characters that populate them, and supporting large numbers of AI characters with different sizes and abilities across large worlds takes development time and performance budget that isn't always available. Havok Navigation for Unreal brings Havok's industry-proven AI character and pathfinding solution to Unreal Engine. With optimized performance, automation utilities, and fast, dynamic pathfinding out of the box. Let's bring things down to one character. This humanoid robot finds paths between the goal points placed in the level. The character uses smooth pathing to create a natural-looking path. This is fed directly into Unreal's motion matching system to help us select better animations depending on the future trajectory. As we can see, this character can jump, vault, and climb, but only in certain places. This is shown through the user edges that the character interacts with, which are automatically placed by the traversal analysis system. This system also identifies opportunities for things like hand plant points that can further feed into the animation system. If I turn on the debug view, we can see a lot happening behind the scenes. The green areas are the nav mesh faces, showing the surfaces the character can move across. The blue arrows are user edges, representing connections between the different surfaces. These need character abilities to use, like jumping across a gap or vaulting over an obstacle. Different characters can use different user edges, and some of them can be one way, like a jump down, others are bidirectional. If we zoom out a bit, we can see that there is a second goal point, but the character isn't navigating to it. This is because the path is currently blocked by debris on the bridge. So let's clear the path. These drones can navigate through the scene to clean up debris. Unlike the humanoid characters, these drones can move along certain walls. This is possible because Havok Navigation supports segments with different up vectors. Only the cleaner drones can use these spaces. Now the area is free on the bridge, the character can hit the second goal and keep moving between all 3 points. If we add more debris to the scene, we can see the small objects dynamically cut the nav mesh. Larger objects use silhouette cutting. This updates the potential routes available and the drones pass towards them to clean up. Let's add more characters to the scene to make use of all this information. Back here on the crates, we have some purple user edges. These are dynamically updating user edges. The crates are expected to move, and due to that, the edges need to be regenerated. When the crates are in motion, they have no user edges because they're not connected to a nav mesh and should not be considered as a potential route. Once they're placed down, the connection is dynamically updated and these can be used for pathing. So let's add some flying drones and move these crates to more interesting places for our characters to use. These flying drones use 3D nav volumes to pass through the world, in this case moving between set goal points to interact with the crates. Each navigable section of the nav mesh needs to be connected by user edges. Generally speaking, the bigger a scene gets, the more user edges it requires, and placing these manually would be extremely time-consuming. Havok Navigation has automatic traversal analysis that identifies these connections based on the character abilities and places them in the level. Connections can also be placed manually by users. When we open up the full level, we get more characters, more nav meshes, and moving platforms. This bridge has a nav mesh on it and moves between the top and bottom platforms. There are yellow user edges connecting the bridge to the nav meshes at either end. Unlike the purple user edges, which occasionally disconnect entirely from pathing consideration, the bridge is always a potentially valid route. These user edges are present to let characters take this route into consideration. The same is true for elevators. The characters can ask if it's faster to wait for the bridge or elevator or to jump down and climb up again. Let's focus in on the ground drones. This blue nav mesh is used by all the drones to pass through the scene. This is possible because Havok supports characters of different radii on a single nav mesh, so you can reduce the amount of memory spent on representing your navigable world. We also get to see collision avoidance in action. The large drones have a higher priority, so smaller ones try to avoid them and can modulate their paths to do this. Characters can also swap between nav meshes. Once a cleaner drone picks up an object, its path is restricted, so the drone switches to using the first nav mesh we saw in green. With everything running through the scene, it's significantly more dynamic and interesting. All of this functionality is available out of the box with Havok Navigation. This demo was created entirely in Unreal Engine 5.7 using Havok Navigation and Havok Physics integrations into Unreal Engine. To see how these features can be applied to your game, reach out to set up a meeting with a Havok representative.